Have you ever wondered what group to use when declaring dependencies? How does Gradle create a class path which includes transitive dependencies from the small list you declare? In this first chapter of the dependency management training, we will dive a little deeper into what these groups of dependencies are and some of the automation Gradle handles for you behind the scenes. When you are developing an application, your code makes use of external libraries. These libraries live in your compile class path to allow your code to compile. Those libraries have their own requirements, transitive dependencies, which are also needed during the compilation of your code. When different libraries request the same transitive dependency, but ask for different versions, this creates a version conflict. Because a configuration can only host one single version of a library, this conflict must be resolved. When the application runs, all or most of these dependencies, including the transitive dependencies, may be needed in the runtime class path. Also, additional dependencies and their transitive dependencies may be needed at runtime that were not required at compilation. You want to be able to control the dependencies available in these class paths in your build configuration, but managing them can get very tedious. There is a lot of automation that Gradle does under the hood to make managing dependencies easier. When you declare dependencies in Gradle build files, you never directly add dependencies to these class paths. Instead, you declare dependencies to groups such as implementation or runtimeOnly. When running the dependencies task, or inspecting a build scan, you will see that the compile class path and the runtime class path are populated with dependencies. You will also see that even though in the build file you declared only the direct dependencies, the class paths include the transitive dependencies. So how does this happen? Let's take a look at the compile class path to understand what happens. Gradle populates the compile class path by taking the dependencies declared in the implementation and compile-only groups in the build file. For each dependency, it then inspects the POM or Gradle metadata file to get the list of transitive dependencies and adds those to the list of dependencies. It does this recursively. After it has finished collecting all of the dependencies, if there are any version conflicts where different versions of a library are requested, provided there is no other configuration that specifies otherwise, it uses the default version conflict resolution strategy of picking the highest version. At the end, Gradle populates the compile class path configuration with the jar files associated with the dependencies. For the runtime class path configuration, it extends from the implementation and runtimeOnly. In Gradle terminology, all of these groups of dependencies are called dependency configurations. The configurations used to declare dependencies in build files are called declarable dependency configurations, or just declarable configurations. The configurations that are resolved into artifacts, such as jar files, are called resolvable configurations. Each resolvable configuration extends from a different combination of declarable configurations. In Gradle terminology, extend means that one configuration inherits all of the dependencies and files from another. It is helpful to get familiar with resolvable configurations relevant to your work and what declarable configurations are involved in each. We will go over the most important, commonly used configurations in this course. It's important to know that dependency configurations are added by plugins. In the documentation, you can see what declarable and resolvable configurations are added by the plugins you use. If you are developing a Java application or a library, your project will apply either the Java application or the Java library plugin. These add the dependency configurations we've seen so far, such as implementation and compile class path. You can see the other declarable and resolvable configurations added by these plugins. If you are working on an Android project, and apply the Android Gradle plugin, you would see different declarable and resolvable configurations available. Similarly, if you were working on a Kotlin project and applied the Kotlin multi-platform plugin, you'd see these declarable and resolvable configurations. Note that in addition to resolvable and declarable configurations, there is a third type called consumable configurations. This is for more advanced use cases, which will be covered in another course. For all the examples and references in the course, we will use Java projects and the dependency configurations added by the Java plugins. However, you can apply what you learn towards other types of projects. Now that you have an understanding of what dependency configurations are, in the next video, you will learn about commonly used resolve and declarable configurations.